how the measurement problem really emerged. When Schrödinger formulated his equation in 1926, it described perfectly how a quantum system evolves as a superposition of possibilities. Everything evolved continuously and predictably in time. But it soon became clear that this elegant mathematical description did not match what we actually observe in experiments. In quantum mechanics, we have two seemingly simple rules. 1. Continuous evolution, Schrödinger equation. The system evolves smoothly and predictably. Everything remains in superposition. 2. Measurement, collapse. Suddenly, you get one single outcome. All other possibilities disappear. The problem: when and why does a system go from superposition to one definite outcome? The theory says everything evolves continuously, but measurement says there is a discrete jump. These two rules do not fit together neatly. Schrödinger himself saw this contradiction very sharply. In 1935, he introduced his famous cat thought experiment to highlight exactly this point. If you take the theory literally, it leads to situations that are physically absurd on the macroscopic scale. Not because the mathematics is wrong, but because a crucial step is missing. The mechanism that explains how and when a superposition turns into one concrete outcome. From that moment onward, physicists faced a clear choice: solve the problem at its root, or find a way to work around it. They overwhelmingly chose the second option. Shut up and calculate was never a deep philosophical stance. It was a practical escape strategy. We deliberately split the process into two separate parts. 1. Dynamics, fully modeled. We describe exactly how all possible states evolve in time. This part is continuous, deterministic, and completely calculable. 2. Outcome, not modeled. We simply assume that at some point, one definite outcome appears. We assign a probability to it using the Born rule, but we do not describe how that choice physically comes about. This is the core issue. The transition itself, the actual moment when superposition ends and a single definite outcome emerges, is explicitly removed from the model. Instead of describing how the system makes a choice, we calculate the smooth evolution of possibilities and then read the outcome afterwards. Measurement is not treated as part of the dynamics. It is merely a registration after the fact. We do not look at how the system arrives at an outcome. We only look at what the system has chosen after it has already happened. This approach works extremely well for making predictions, because the probability distribution is correct and the statistical outcomes match experiment. You don't need the actual mechanism to get useful results, but that success comes at a price. This is the fundamental limitation. A method that deliberately skips a crucial part of the process can never solve the problem in which that very moment is central. It can only bypass it. And that is exactly where the real opening lies. The fact that current predictions work well does not mean the theory is complete. It only means the theory is usable despite a missing mechanism. If that missing mechanism can be made explicit, for example through a logical, local criterion operating inside the process itself, then we would gain not only a deeper and more consistent description of reality, but also entirely new computational and predictive possibilities. This matters deeply because it touches the very limit of human understanding. When you understand better, you logically become better overall. It is the same as a car with a broken turbo. It still drives but never reaches its true maximum performance. An athlete with an injury. He still competes, but never at his real potential. The fact that something works does not rule out that a better, more complete way exists. We have spent decades staring at the stars, investing billions in giant satellite dishes to catch the faintest ripple in the universe. We are searching for intelligence, for a sign, for proof that we are not alone. But while we peer outward, we ignore the fundamental flaw in the way we look at reality itself. In our highest physics, we have created an official dogma. We see a particle behave like a wave of possibilities until it is measured. At that moment, the world clicks into a single fact. We call this the measurement problem. And the official claim of our science is as bizarre as it is arrogant. This process is fundamentally random. No human can ever solve this. The logical quarantine. Imagine a truly intelligent civilization. To them, that click is not a mystery, but a mechanism. They master the transition from possibility to reality. They likely communicate through the direct manipulation of that fundamental transition, the turbo of the universe. But what do? Because we have decided that this transition is random, we categorize their signals as natural noise, as chaos, as background radiation. We are like a cat staring at a television screen. The cat sees flickers and light but doesn't understand the information transfer because it doesn't understand the mechanism of the screen. This is our logical quarantine. We search for intelligence in the stars while we cannot even explain the intelligence in our own interaction with the atom. The myth of the thinking species. But here is the most uncomfortable truth. We are not the thinking species we claim to be. We are supercopiers. In nature, a bird copies a song to survive. A predator copies a technique to hunt. Humans do the same, just on a larger scale. History shows that true intelligence is rare. One individual, the somebody else, finds a mechanism, a wheel, fire, a formula. The rest of civilization doesn't understand it, but they copy the success. Not because they grasped the source code, but because it increases their chance of survival. We confused technological success with intellectual understanding. We act like a dog learning a trick for a treat. The dog doesn't understand the biochemistry of the treat. He just understands that sitting produces a result. The arrogance of the we. The most dangerous sentence in our language is, "We don't know. Therefore, it is unsolvable." This is the voice of the pack defending its territory. By claiming that no human can solve the measurement problem, we mask our own laziness. We have turned our ignorance into an official claim, so we can keep copying safely without anyone questioning the foundation. True intelligence never places itself above the model. But humanity has woven its own ego into its theories. We have framed reality within our own biological limits. We are a species sitting in a fishbowl, claiming the ocean doesn't exist simply because we've reached the edge of the glass. And here is the beautiful, ironic part. Now that you are hearing this, you probably don't know what to do. Your brain is searching for an existing box to put this information in. But that box doesn't exist. You will likely fall silent and wait. You are waiting for someone else to take the first step. You are waiting for this logic to be officially approved by the very system we just unmasked. That is the copy circle in action. That is the survival instinct paralyzing your logic. To escape, you must make an endogenous step, a move from within, independent of the herd. The question is not whether this information is true, but whether you are capable of seeing the turbo without waiting for the rest of the pack to point at the hood. Probably not. And that is exactly why the measurement problem, after 100 years, is still a mystery. Shut up!